Another thing, we have our admission is going on for 2027 IIT Jam. So those are interested for 2027 IIT Jam, or if your colleague or your juniors are interested, then you can convert them this. So we are providing both offline and online coaching. So obviously it is better for better if you join offline, so that we will get more facilities and more attention for the studies. But if you choose online, then we'll try to solve your problem, then your doubt through live classes. And in our online classes, we don't provide the previous year video. We always provide fresh video. So if you join online courses, uh, the video will be coming in every week, and all the doubt clearing classes will be live, and PYQ analysis will be live. So if you want to join our institute for the next 2027 preparation IIT exam, GATE, JSI, then you can call us or visit our website, or you can go out to our website and register there. We will call you, and if you have any doubt, then you can mention this in comment section, or you can WhatsApp us. You can provide you can get the number from the website. Hello everyone, so welcome to SP Geology. So today we'll cover the economic geology of question from CUET from 2020 to 2025. So let's start from the first question. The Jadugoda mine in India is famous for. Jadugoda mines, it is situated in Jharkhand region, which is along your Singhbhum shear zone, where you'll get uranium, copper type of deposition. So which is the Jadugoda mines, which is famous for uranium deposition. So always remember, it is a famous place. In most of the entrance exam, you will get this Jadugoda mines question. What are the deposition you will find in Jadugoda, or in table match you also get this Jadugoda. So it is famous for uranium deposition. So the principal depository, which is Singhbhum copper iron belt, copper uranium belt, where you will find uranium in these regions, Bagjata, then these Narwa Pahad, then Tumardhin, and other these regions. You can pause this and write down all these regions are under your Jadugoda mines, where you will find different your mines where you will get uranium. Then other than Jharkhand regions or Singhbhum region, you will find in Gogi region, that is in Karnataka, that also famous for uranium deposition. Then there is another you will find in Tumlapalli, that is under your Kadapa supergroup under Vampel formation. So all other deposition you will get also deposition in Odisha, that is in Jharsuguda region. Some critical mineral, not uranium, but in critical mineral you will find the niobium, tantalum. Then in Chhattisgarh you will find in region, that is Bodal. So these are the different uranium depositions that are found in India. Most important one is your Jadugoda mines. Then come to next question. So Kudermukh mine in Karnataka. So Kudermukh is famous for iron deposition. So which belongs to your Dharwar supergroup. So Kudermukh, it contains banded magnetite quartzite BMQ that belongs to Baba Budan hills. So the Kudermukh mines in Karnataka is known for magnetite, that is famous for iron deposition, and that way in iron you will get magnetite deposition, where you will get a horseshoe shaped folded unit about 40 km length, that is called Kudermukh scarp. Kudermukh scarp. So answer will be magnetite. Then comes to next question, that is about your petrol deposition or oil gas deposition. These Nahar Katia, Kalol, Ankel Sore, these are famous for your oil and gas deposition. Oil and gas deposition, that is petroleum and natural gas. So I've made a table where different oil fields in different part of the India. Where in Assam you will get oil deposition in Digboi, Naharkatia, Moran. So Digboi and Naharkatia you will get in Assam, Assam region, where the Digboi deposit, Digboi oil field deposit in Tipam sandstone, if you remember. So it is capped by Girizon clay. So Digboi, Naharkatia, Moran, these are in Assam. Then Gujarat, you'll get Ankleshwar, Kambar, Kalol, Mehsana, Nagaon, Sanand. These are the region that found in onshore. These are onshore production within the land, you can say. Then Rajasthan, you have Mangala, Saraswati, Rajeshwari mines. These are also oil producing. Then in western offshore region, that is Mumbai High, Basin, Aliabet. These are offshore within the ocean. That is belongs to Miocene strata. Then eastern offshore you will get in Rawa, then Nariman, Kovilapal, that is in your Rajahmundry region, Krishna Godavari Valley or Kaveri Valley. So these are your major oil producing regions of India. So try to remember all this. It's very helpful for your economic exam, because in economic exam you see most of the time most of the questions are asked about the place of deposition in table match or in general MCQs. Next question, your reservoir rock of Digboi oil field. So Digboi oil field, that is in Assam. So Digboi oil field, it is said that Digboi oil, the reservoir rock, it is Tipam sandstone. It is Tipam sandstone. You will find it in a tertiary of Assam succession. Tipam sandstone that belongs to Miocene. That belongs to Miocene. Now to next question. So it is given placer gold deposit are mostly occurring. So placer gold. So what is placer deposition? It is a mechanical concentration deposition. It is mechanical concentration deposition. So I will briefly explain what is mechanical concentration. So mechanical concentration is simple, the separation of heavier one from the lighter one. So heavier one generally, as we are talking about economic deposition, so mostly the metals are get deposited which have a obviously high specific gravity or high density. So when suppose the water is flowing, wind is flowing, so according to their energy, they will transport or displace sediments. So when the energy of these transporting agent decreases, it is only able to transport the lighter one, the heavier one will get settled at some places. So that is called as a mechanical concentration. It is simple called as the separation from the heavy to the lighter one. So any deposition that occur because of mechanical concentration process is called as your placer deposit. So there are different placer depending upon the agent involved. Alluvial placer, it is a placer that produced because of running water. Then aeolian placer, it is a placer that occur because of wind action. Then colluvial, alluvial, it depend upon the hill slope and hill your foothill. So during suppose a flowing of water, suppose you consider river is flowing in mountainous region, when it enters to the plain land, they give deposition at foothill of the mountain, what will you call alluvial fan. So during the any places where the velocity of the agent or erosional agent decreases, in that place it will give deposition some heavier things. So now comes to our question, placer gold deposit. So gold generally it present within some host rock. So then the host rock will expose to the surface, then it will disintegrate. After disintegration, mostly the rock that associated or the gold that associated with the rock, they generally present in the mountain, because when mostly gold are deposited in orogenic belt, there is a process called orogenic gold deposition. So they are in the mountainous region, so mostly they are affected by river action. So after erosion, the after disintegration of the rock, the gold will be free from the rock. Then it will gradually transported by river action, then deposited at places where the velocity of the river decreases. Like you take the example of the alluvial fan region, you can take the example of your meander region. You will get point bar deposition. You'll get where one tributary meets the mainstream. All these regions are your site for placer deposition, and gold also produced in that region. So alluvial is a potential you can agent which can deposit gold. All other are not that much potential. Aeolian, you will get your rare earth element in aeolian deposition, or rare earth element also found in beach placer. Mainly they are found in beach placer. So your alluvial is has the potential to produce that your placer deposit. So answer will be here, more appropriate will be alluvial. So the placer gold deposition occur in alluvial region. Then comes to epigenetic ore deposits are those which formed. So epigenetic, there are two types of ore deposition. One is syngenetic, another is your epigenetic. So one is syngenetic, one is epigenetic. So syngenetic type of ore deposition that occur during the formation of the rock. When the rock is forming, in that time, the economic ore that enclosed within the rock. That means before the solidification of the, or at the time of the solidification of the rock, the economic ore will also deposit within the rock. You can take the example of chromite, where the chromite is a syngenetic type of deposition. Or you can take the example of magmatic concentration deposit. All the magmatic concentration deposit are syngenetic. Then epigenetic, then after the formation of the rock, when a rock is formed in process of magmatic or your other sedimentary or metamorphic, after the formation of the rock will undergo some tectonic activity, or rock contains some your structural weakness, you can say, like fracture, joint. So those are the site where the ore will or mineral solution will accumulate and give deposition. So in that type of deposition, the ore deposited in a rock which already produced. That means after the rock formation, that is called as your epigenetic. So hydrothermal type of deposition, they are epigenetic. We have discussed this mechanical concentration. These are epigenetic, because the in case of mechanical concentration deposition, the ore body that is already produced, then after formation they will disintegrate or separate from them and deposit in other places. So that means it is epigenetic. So mechanical concentration is epigenetic, hydrothermal deposition is epigenetic, supergene enrichment is epigenetic, and syngenetic, your magmatic concentration is syngenetic, sedimentary deposition is syngenetic, that is produced at the time of sedimentary rock formation. So here epigenetic ore deposit are those which formed in the same time as the host rock. The answer will be in the same time as the host rock. Come to the next question, that is your sulfide ore of mercury. So mercury, it is Hg. So among these options, your cinnabar. Cinnabar is a ore of mercury, which is HGS, mercury sulfide. Then other option, your urgite, it is zinc sulfide. The orpiment, it is ore of arsenic, AS2S3, sulfide of arsenic. Then real gar AS4, or you can write down ASS, will be AS. So your answer will be cinnabar. And remember, all these are also very important. They are ore of arsenic, and this is ore of zinc. So next question, your gondite and cordite. So gondite, cordite, they are found in Eastern Ghat region. So which is famous for manganese deposition? Answer will be manganese. So gondite, it is a metamorphosed manganese rich sedimentary rock that contain garnet, quartz, MN minerals. Garnet, quartz, you will find spessartite. Then cordite, it is a metasomatic rock that also contain MN oxide, rhodonite, spessartite. So it is found in Andhra Pradesh, and gondite is also named. It is found in Madhya Pradesh in central India. It is also named on a tribe, that Gond tribe, and codurite, it is also named in a region in the border region of Andhra Pradesh and Odisha, that is Kodur area. It is also named on the basis of that codurite. So these are potential ore of manganese which is found in Eastern Ghat region. So next comes to another question, that is your Rampura Agucha mines. Rampura Agucha mines, it is famous for PBZ deposition, which is found in Aravalli region. So Aravalli region, which are which has three important deposition of PBZ. That is, one is your, remember, Rampura Agucha, another is your Rajpura Dariba, another is your Jawara. So these are three very important depositions that occur in the Aravalli region. Rampura Agucha, Dariba, Rajpura, Sindeshwar, Kurd, then Jawara deposition. So these two, they are produced by SEDEX, sedimentary exhalative. It is a hydrothermal process. Remember, it is a hydrothermal process. Sedimentary exhalative, which does not involve any volcanic activity, whereas VMS, you study VMS, volcanogenic massive sulfide, that is a hydrothermal deposition that related with volcanic activity. But this is not magmatic, it is only related to volcanic. But SEDEX, it is sedimentary exhalative, which is also hydrothermal deposition, which is not related to volcanic. These are also it is a difference between VMS and SEDEX. Then we have MBT, Mississippi Valley type deposition of Jawara. So these are three very important deposition of PBZN. Remember, along with PBZN, here we will find silver. So Rampura Agucha, it is in Bhilwara district, and the host rock of Rampura Agucha is graphite mica sillimanite schist. Graphite mica sillimanite schist. So Rampura Agucha, it is famous for PBZN. So answer will be PBZN. Let's see what are the other Dariba, Rajpura, Jawara. What are the other depositional host rock here? Then Rajpura, Dariba deposited occur in these regions: Dariba, Rajpura, Sindeshwar, Kurd, Sindeshwar, Kalan, Bamnia, Kalan. These are your host rock is your dolomite, and in sometimes you will get graphite mica schist. And Jawara region also get your dolomite, that is host rock. These are the regions or places where you will get your PBZN deposition. Another deposition in Rajasthan is the Kayara PBZN deposition, that hosted by metasedimentary rock, that is called mica schist. So these are the first three are very important. This is also remember, this is also present in Rajasthan, the Kayara PBZN deposition. So next question, will move to polymetallic nodules. Mostly polymetallic nodules are called as your manganese nodules, mostly. So polymetallic nodules means these are nodules type of deposition. You know, in sedimentary structure, if you have studied, there are two types of deposition. One is concretion, one is nodules. So concretion is a type of precipitation deposition that occur within the host rock, within the, you can say, pore spaces of the host rock or interstices of the host rock. And nodules, it is deposited on a host rock or around an host rock. All are spherical deposition. So polymetallic nodules, or mostly it is manganese nodules, they are also spherical type of deposition. Mostly they occur in deep ocean basin. They occur in deep ocean floor. So manganese nodules, we'll discuss about manganese nodules. This is very important. Manganese nodules are, you can say, spherical shape, to few centimeter in diameter. They always require a host to grow. So either they grow on around a rock or a fossil fragment. So their mechanism it is not particularly developed how the manganese nodules are formed, but there are some explanation that is given. One is for precipitation from seawater around substrate nucleus. So there are some your pH condition where manganese or an iron precipitated within the ocean. Then upward diffusion of metal in sedimentary through pore spaces, that is your hydrothermal circulation. Suppose this is sea floor. Suppose let's take this is sea floor. There will be metal that can your upwardly diffuse to the your sea floor from the subsurface region. So they can also contribute to manganese deposition. Then bacterial activity, some bacteria has a capacity to bind minerals. I can take the example of stromatolites. So they can also give deposition. These are three processes that explain the formation of manganese nodules. So manganese nodules that are produced in the deep sea floor, particularly since late Miocene time, that means from the recent time it is depositing there, and nowadays it is we try to explore that type of manganese from the deep sea. So answer will be deep ocean floor. So come to next question, that is tin tungsten SnW. Mineralization common associated with tin tungsten deposition as called as Grisen deposition. Grisen deposition. It is a hydrothermal process, so mostly occur in granite. It is found in granite. So answer will be granite. So always remember, tin tungsten that deposited by the partial melting of your granite, then with your high fractionation condition or extreme fractionation condition, they give deposition of SnW. So we don't have much time to explain the whole Grisen deposition, but remember, with gradual fractionation, the residual melt, they get more enriched in tin and tungsten. That is the main process here. So tungsten deposition are often found closely associated with tin deposition, because though they have different chemical characteristics. So these are ore of tins. It is very important: cassiterite, SnO2, and stannite, which is copper and iron. Then tungsten have these four types of ore: wolframite, which is FeMn. Then steelite, you will get CaW. Then tungstenite, it is W, and tungstate, it is WO3. It is hydrated. These are the ores, and they are associated with granite. So granite is the most common host rock for both tin and tungsten mineralization, as I have told you. So it is produced by anastasis of the lower crust and then empties of the mid crustal level, growing enough or extreme fractionation to develop S-type characteristic. S-type your granite is suitable for the formation of the SnW deposition. So come to next question, that is your East Coast bauxite deposition. So East Coast bauxite that is deposited in Eastern Ghat region. Eastern Ghat region that deposited in Odisha, you will get in Epigenetic district, that is in Kalandi, Balangiri and Koraput region. And in Koraput region you will get bauxite deposition in Panchmatwadi, that is very famous deposition. So bauxite deposition, mostly remember, the source rock of bauxite can be any rock which is aluminum rich. The bauxite is an ore of aluminum. If any rock that is richer in aluminum can give bauxite deposition. So in Eastern Ghat you will get khondalite. In Eastern Ghat you will get khondalite, that is the source of bauxite deposition by weathering. So bauxite produced by residual concentration deposition. Residual concentration deposition means any rock that will undergo chemical weathering, where all the other constituent of the rock will be removed and aluminum will be get deposited in the place. So that is a chemical precipitation deposition, where the deposition that is controlled by pH condition, where aluminum will not leached, other constituent will be leached. So there are certain conditions for the formation of the bauxite that we will discuss here, which is very important. Remember all these things. What are the different conditions that produce bauxite or aluminum? So favorable climate. What is the climate? That is tropical monsoon climate, which is temperature is between 23 to 26 degree and annual rainfall between 1200 to 4000 mm. It is very favorable for your bauxite deposition, because as we are talking about chemical weathering, we require water. So this is the favorable condition. Then suitable drainage. Why we require drainage? To remove all the unwanted constituent from that region. That's why we will require a good drainage system or suitable drainage system. Then geomorphology, most lateral bauxite deposit in blanket type deposition, now covering the ancient. They deposited like a blanket on the ancient plantation surface that is desiccated by valleys. Then forest cover required. They required to decompose the rock by your biological means. Then rock type, as I have told, any type of rock that should be aluminum rich. It can be igneous, it can be metamorphic, it can be sedimentary. Then tectonic condition, that should be tectonically stable region. It should be technically stable region. So these are the condition for the formation of the bauxite deposition, or you can say aluminum deposition. So our answer will be chondrite. If you are considering Deccan trap, that will be basalt. Then comes to your Hutti goldfield mines. Hutti goldfield, Kolar goldfield mines, they are in Dharwar in the eastern Dharwar where they deposited along quartz veins. Remember, quartz veins, it is produce gold deposition, which is a hydrothermal origin. Now comes to which of the following ore deposit are magmatic concentration deposition or magmatic segregation? Magmatic segregation deposition are syngenetic deposition. Mostly during the formation of the rock, the economic mineral will segregate on the host rock, because economic mineral are metallic. They settle down because of your gravity, because of gravity separation. So that is your chromite deposition. Always remember, chromite is magmatic and produced by segregation deposition. You can take the example of Shokinda chromite deposition, and chromite deposition occur in early magmatic deposition. So that's why chromite deposition occur at high temperature and associated with mafic and ultramafic rock. So chromite deposition will be the answer. Bauxite, you will know, it is residual concentration, which is sedimentary. Gold deposition is hydrothermal. Copper deposition can be hydrothermal, that is porphyry copper deposition. Copper can also produced by magmatic, but it is late magmatic. So answer will be chromite deposition. Then which of the following mineral is carbonate of Mn? So manganese is a different ore. So Mn carbonate is your rhodochrosite, that is MnCO3. Then other, that is calcite, it is carbonate of calcium. Witherite, it is carbonate of barium. Siderite, it is iron ore, carbonate of iron. So I have listed this. It is little blurry, but I'll read out all these minerals. Fasting, your pyrolusite, it is MnO2. Then silomelane or cryptomelane, it is BaK MnO2. Then manganite is Mn hydrated OH. Then osmanite, it is Mn3O4. Brownite, it is Mn2O3. Oxides are, these are oxides. Then bixpite, it is MnFe3, it is oxide. Then newsite, it is Mn4 plus, Mn2 plus, and your OH3 plus. Then manganese, it is MnO. Then rhodonite, it is SiO3, it is your silicate of manganese. Tephorite, it is also silicate of manganese. It is Mn2SiO4, which is belongs to olivine group. Then rhodochrosite, it is MnCO3. Then spessartine, it is garnet, Mn3Al2SiO4 whole 3. Then uberite, it is MnO4 WO4. This is tungsten is related here. Then these are all others. Brinesite, it is MnO2. Then totokite, it is MnBaC, Mg, Mn3O7, and it is hydrated. Bucerite, it is MnO2. Okay, then we will get these manganese nodules. Okay, I'll give you a proper table here. It is little blurry. I think you cannot see all these names. I'll replace this with a particular Word file, so you can easily view this. So next comes to next question, which is given below. Two statement: one is labeled as acetation, one is labeled as resin. Gypsum are lower density than anhydrite. So what is gypsum? It is CaSO4 2H2. This is hydrated. volume of the hydrated mineral are more than the volume of anhydrous mineral. So obviously, if a rock that is hydrated, it has more volume than a dry mineral. So gypsum has low density than anhydrite. Anhydrite is CaSO4. So what is density? It is mass by volume. The rock that has more volume will have less density. Will have less density. So that indicates the density in the inverse proportional volume. So in between CaSO4, 2H2 that is gypsum and CaSO4 that is anhydrite. So gypsum has more volume. So that's why it has a lower density than anhydrite, and that reason being volume of the hydrated minerals are more than the volume of anhydride minerals. So the both A and R are true and R is the correct explanation of A. So answer will be A. So come to our next question, that is the two statement is given. One is fossil fuel supply approximately 85 to 90% of the global energy consumed. We all know the fossil fuel is very important. In present condition, we are facing these problems because of the war between these countries, that is in Iran. So fossil fuel supply approximately 85 to 90% of the global energy. It is obviously correct. Then nuclear power is considered as a conventional source of energy. So there are two types of energy. One is conventional source of energy, and another is non-conventional source of energy. Conventional energy that refers to the traditional energy source that have been used for a long time. That is called conventional energy. You can take the example coal, petroleum, natural gas, hydropower. Non-conventional energy refers to the newer or alternative energy source. That is your solar energy, wind energy, geothermal energy, tidal energy. These are nuclear power. These are non-conventional. That means here it is given that nuclear power is considered a conventional source of energy. It will be incorrect. The statement 1 is true and statement 2 is false. So answer will be C. So come to next question. We have two acetational region. Here dispersion halos are formed in area around the source. So what is a dispersion halo? So during deposition of any your ore body, suppose this is an ore body. Okay, during deposition of ore body, you will find concentration of that ore body around the main ore body. This is called as your dispersion halo. So there are two types of dispersion halo. One is primary, another is your secondary. Suppose there is an ore deposition here. At the place of the ore deposition, nearby that deposition, you will get higher, or you can say you will get that ore deposition or that ore mineral in the nearby region. We use one term, that is background value. We have studied about the different percentage of element or in the crustal region. So that percentage is considered as a background value. Suppose iron, suppose copper. They have a certain percentage within the crust, that is a normal value. In places of ore deposition, that value or that percentage will be more. Suppose aluminum, it has a percentage, your 8 percentage in the crustal region, but in the region of aluminum deposition, that percentage will be higher. So suppose aluminum deposition here, the aluminum concentration will be higher here, and the nearby region is also higher, but not as much as the ore part, but it will be higher than the normal value or background value. So if there is aluminum here, then around its region, you will get aluminum. That is called as your dispersion halo. That means from the main ore, they disperse to the nearby region. There are two, one is primary, secondary during the formation of the rock, or after the formation of the rock, because of weathering and erosion, they can disperse to the nearby region, which is very helpful to locate the main ore deposit. Because during geochemical exploration, we measure the percentage of minerals within the crust. in the region where we'll get more than the background value, we assume that some deposition is present here. So dispersion halo formed an area around the source. This is our source. The dispersion halo will produce around the source. So elemental dispersion is caused by natural process outward movement of the certain metallic element from the source. So it is produced by weathering erosion, that is natural process where there will be outward movement of the source mineral from the main source. That's why both A and R are true, and R is the correct explanation of A. So next question is your drill hole diameter and drill hole nomenclature table match, where these diameter nomenclature are universally accepted. So it is a data type of question. You just have to remember what are the different nomenclature of drill hole and their diameter. So I have given you a table here. So drilling type HX, it is 99.20 mm, and core diameter is your 76.20 mm. Then NX, then BX, AX, EX. You can pause this and you can write down all these your nomenclature that is given for hole diameter and core diameter. So let's come to our question that is given your BQ, AQ, NQ, HQ. So that means our line BQ, HQ, NQ, AQ. So BQ 60, then HQ 96, NQ 70, AQ 48. And in decreasing order, you send HQ, NQ, BQ, AQ. HQ, NQ, BQ, NQ. So HQ will be the highest, that is BIV. The only one option is BIV. Then A first, that is BQ. Then BIVC second, that is AQ. Then D third. The answer will be B. Answer will be here B. So just have to remember these things. This is a data question. So come to the next question, the detectors used in seismic reflection survey. So in seismic reflection survey, we use geophones to record the say the vibration during propagation of the seismic wave. Then electrodes, it is used in resistivity method, and scintillating counter, it is used in your radiometric exploration. Remember, this sonnet is not for sounding, it is used in borehole well logging. Okay. So next question. Which of the following is the best guide for taking further mineral exploration activities? Further means there is already a mine established or already some deposition established. We have to further expand the region. So it will be very suitable in ancient mines region, because there is already established a deposition. Then we have to further in the you can say in the ancient mines, we already know the strike and deep of the deposition, so that we can take further exploration that strike and deep condition, so which will be very suitable. Other condition, it is not indicative of any deposition. They are the, you can say, presence of host rock, presence of lineament, presence of shear zone. There is no confirmation of deposition in these conditions. So here there is a confirmation. So that's why it will be very easier, so that we can take further exploration activities. So this will be the answer, presence of ancient mine. Next question, one of the following geophysical method is most commonly employed for exploration oil gas. So always remember, in case of exploration oil gas, we always use seismic method. Seismic method is very suitable for oil and gas exploration. So I have given this table. So I have given this table so that you can remember the different method and their suitable deposit type. So you can pause this and you can write down all these method, their major parameter and suitable deposit type. It will be very helpful for other exams. So next comes to a horizontal tunnel through which concealed ore bodies can be accessed is called as. So these horizontal tunnel, they are used in underground mines. Your zinc, sap, zinc is not used in mining term, so it is not related to mining. Sap, audit, decline, they are all related to mining term. So here is a diagram that indicates all these things. So let's so these horizontal tunnel, they are called as your audit. You can see here this is a horizontal tunnel that got across the ore body, that is called as your audit. The decline, these are pathways that is used to transportation of vehicles, rubber vehicles. Then shaft, it is a vertical downward thing that used to transport, I can say through, you can say lift type of thing. This is which is transport to used to transport laborers or other human beings. So then from the shaft you will access the ore body by cross cut. Then if uh, you can excavate the ore body from lower level to higher level, it is called as a raise. From higher level to lower level, it is called as your winch. It is called as your winch. Then this is your winch from higher to lower, and from lower to higher it is your raise. This is your cross cut to access the ore body from the shaft, and this is a stove where there is when you excavate something from the ore body, the empty part is called your stove. So these are different terms that are associated with underground mines. So next question, your table match. We have different ore types and their composition. Pyrite, it is ore of iron FeS2. Then galanite is ore of PbPbS. Sphalerite is ore of ZnS, and chalcopyrite is ore of copper and iron. So answer will be A2. There is only one option, A2, B1, C4, B3. Option B will be correct. Then syngenetic deposition. So syngenetic deposition, it is, we have already discussed syngenetic deposition. It is produced at the time of rock formation. So it is simultaneously with the host rock, and after the host rock, it is epigenetic. This comes to another question, that is platinum deposit. So platinum deposit always associated with early magmatic deposition. It is associated with all mafic and ultramafic rock. So platinum deposit of magmatic origin are mostly associated with mafic and ultramafic rock, because it is early magmatic. Any deposition that is early magmatic, that is associated with mafic and ultramafic rock. So what is platinum deposition? It belongs to platinum group of metals that we call PGM, which include your platinum, palladium, rhodium and ruthenium, and iridium and osmium. These are belongs to PGM. Remember, it is very important. PGM deposition. So the PGM concentration and sulfur content, because sulfur used to leach the PGM metals, and they deposited as a segregation deposition or dissimulation deposition, you can say, at the earlier magmatic crystallization. So primary PGM deposition of magmatic origin typically associated with basic to ultra basic intrusion, where immiscible sulfide liquid concentrate the PGM. In PGM, sulfide acts as a scavenger to remove the PGM. So this thing will elaborately will study in MSc classes, where you will completely study the process of PGM deposition. For now, you remember PGM deposition, it produced at high temperature, that's why it associated with the basic and ultra basic rock. Remember, any deposition that produce, that is chromite, that produce at higher temperature, they always associated with basic and ultra basic or mafic and ultramafic rock. Next question, late magmatic deposit include. Late magmatic deposition, obviously it there are two main type of late magmatic. One is immiscible liquid and another is residual liquid. They can be segregated, they can be injected. So magmatic chert deposition, there is no magmatic chert deposition. They are chert deposition are always sedimentary. Then magmatic deposition, iron and titanium, these things, iron and titanium, they can be enriched in residual liquid during progressive magmatic crystallization. So they can be produced during magmatic late magmatic reaction. So it will be the answer. Diamond deposition kimberlite in magmatic origin, that is your early magmatic, because diamond associated with kimberlite is produced at higher temperature. So mica deposit in Jharkhand, this mica deposit in Jharkhand, they are pegmatitic deposition. So come to next question. The lowest permissible metal content of an ore generally expressed in percentage referred to as. So what we call tenor. So tenor is the metal content of an ore that will also consider as lower permissible metal content of an ore generally expressed in percentage. That means any your ore body, they have the metal but they contain the metal in certain percentage. You can take the example of suppose magnetite, it contains 72% of iron. Hematite, it contains 70% of iron. That is called your tenor of the rock. So tenor is, that's why indicate the permissible metal content of an ore. Next question comes to resistivity sounding. So resistivity sounding, it comes under resistivity method, where we use a different type of method, that is your Weiner method, Slumber's method, according to the electrode arrangement. So what we will do in resistivity method, I will briefly explain. In resistivity method, we supply current to the subsurface region by putting electrodes. Then we measure the resistivity, or we supply the current. We measure the potential difference by supplying the current. Then by using the formula your V by I, we measure the resistivity. So from the resistivity, we will know whether there is metallic deposition or not, because resistivity gives you that condition. So to measure to certain depth, or to measure lateral, we use different method. One is resistivity sounding method, that is called as a vertical electrical sounding, where we access more depth, and another is horizontal electrical profiling, where we cover more lateral regions. So our answer will be here measure vertical variation in resistivity. Moving on to next question, the spontaneous potential logging method, that is your SP method. The SP method, it is under electrical method, so where it measures the natural electric potential current, that is from the it will measure the Earth's current, because Earth has its natural current, which we call the telluric current, that occur because of oxidation and reduction. So these are different log variety, which is very helpful for your entrance exam. There are question asked which of the following is porosity log, which is the following is your permeability or lithology log. So permeability, lithology log are gamma ray log, cell potential log. These are permeability and lithology log. Then if you know the diameter or size of the borehole, it will be called as a caliper log, which helps to determine the diameter of the log. Then porosity log, we have density log, sonic log, neutron log. They are called as your porosity log. They measure the porosity. Then electrical log is your resistivity log. So remember the thing, it's very important. Then an important advantage of the radiation of logging over most other is that they may have recorded in. So radiation logging, we use gamma ray. So gamma ray can almost penetrate anything. So whether it is a cased hole or open hole doesn't matter. So that's why during your radiation of logging, open hole, cased hole, either open, cased, all can be used during gamma ray logging. So ABCD, because gamma ray can penetrate anything. So that's why all will be correct. So explanation is given here. Radiation logging, such as gamma ray logging, measures natural induced radioactivity rocks around borehole, and radiation logging is not affected significantly by casing a borehole fluid, because gamma ray can penetrate, still causing casing and your drilling fluids. Next comes to placer deposits are generally formed by the process of that. We have discussed placer deposit that are produced by mechanical concentration deposition. So early magmatic will be incorrect, late magmatic will be incorrect, high pressure temperature metamorphism, it is metamorphism. So this is the correct answer. Mineral concentration by flowing surface water depositing high density mineral in stream or along coastline, that we have already discussed. The high density mineral will be deposited, low density or low specific gravity mineral will be flown out. So answer will be D. Next, diamond occur in commercial quantity. It is very important to remember, diamond always occur with kimberlite. You find some diamond in lamprophire, lamprite, but most diamond occur commercial quantity in kimberlite. Always remember, diamond occur with kimberlite. Next, we have a table match. We have a different deposition and their area. Chromite deposition, our very own in Odisha, that is in Sukinda. Then iron deposition, it is in Boiladilla, that is in Chhattisgarh. There are two depositions, that is in Boiladilla region, and in you will take Durg region, you will get iron deposition in Chhattisgarh region. Copper deposition, it is in Khetri. In copper you will get in Singhbhum, Odisha, that is in your Singhbhum copper belt. Then copper you will get in Khetri. Copper you will get in Malans Khand, that is porphyry copper deposition. Then you will in southern India, Ingladhal copper deposition in Karnataka region. You will get copper in also in Aglingundala in Kadapa basin. Then coal deposition in Jharia. So coal deposition in I think in the following next questions, next section questions, I gave deposition about the coal deposition, all the coal deposition in India, so that will be helpful. So see what will be the answer. Chromite deposition Sukinda, A third, there is only two options, A third, B it is 1, it is I, B not I, so B fourth, that means the answer will be D. Answer will be D. So next question, tenor. Tenor I have discussed, that is their metal content in an ore. Then unwanted associated minerals are called gangue minerals. So answer will be metal content. The next question is a table match question where we have different minerals and their ore. It is also very important. Just you have to remember all the ore of the particular ore mineral of the particular element. Suppose here you have iron, it is an ore of iron has a ore hematite. Then chalcopyrite, it is can be copper. Then cinnabar we discussed, it is mercury. Pitch blende, it is uranium. So hematite third, there is only one option. It will be very easier. That is option A will be correct. Next comes to your Kiruna deposition. It is in Sweden. It is a early magmatic deposition. It deposit magnetite. So mostly, if you face any economic type of question, all questions are mostly related to India, because in our syllabus it is given economic deposition or mineral deposition in India. This question, it is a type of something different that is given about the Sweden, but it is you will find this thing in Umeshwar Prasad book where it is given in Sweden. So that's why it is asked here. Just remember, it is in Sweden that is given magnetite deposition. Next question, Khetri copper belt. So there are different copper belt we have discussed. Singhbhum copper belt, Khetri copper belt, then Ingladhal copper belt, then your porphyry Malanskhand copper belt. So the Khetri copper belt is up. What is the origin? So we have Singhbhum copper belt. It may hydrothermal origin, which is uranium belt. Then Malanskhand copper belt, it is also porphyry copper, which is hydrothermal. Khetri copper belt Rajasthan, it is sedimentary diagenetic. So answer will be sedimentary. Then Ingladhal copper belt, it is Karnataka, it is volcanogenic type. So our answer will be sedimentary. So come to the next question. There is two table matches given here. Wow. We have technical properties and their definition is given. What is mineral exploration? It is to discover the mineral deposition then mine development to establish the entire infrastructure, then splitting to recover the metals from the mineral concentrate, and refining to purifying the metal. So what will be our answer? A is given second. Then we only have an option with A second. B we have given main mine development, which is V. C splitting is recovering metals, then refining. So answer will be C. So here I given the different stages of exploration. So arrange the following prospecting methods for mineral exploration in order their execution. So first thing is given geological mapping, then laboratory analysis, then topography survey, then sampling of old mines. So what will be the sequence? So next you will arrange them. First there will be topographic survey. So in a region, if you want to indicate or to indicate some deposition, or you have to do some survey, you will require first topographic, and you will do a topographic survey. Then from the topographic survey you will do a geological mapping, then you will do sampling, then you will do laboratory analysis, then you can somehow prospect some deposition in that region. So answer will be CADB. So these are different stages of exploration. One is reconnaissance, this is called G4, then prospecting G3, general exploration G3, then G1. So these are different stages of exploration where you will explore a particular virgin area, where in these stages you will confirm some deposition which leads to establishment of any mines. So next question, your gamma ray detector instrument used in modern radiometric survey. So in radiometric survey we use two instrument, Geiger and scintometer. So in modern technique we will use scintometer. So remember, scintometer it is used in modern technology. Gamma Geiger it is used in ancient time, which is not that sensible. Next question, which of the following is a tertiary coal field deposition? So all the coal field or coal deposition in India divided into two parts. One is your Gondwana, one is your tertiary. So quaternary deposition type, that deposited during Permian around 250 million years. These are the major formations. And tertiary between Eocene to Miocene, Cenozoic between two. These are the approximate age. So this is the statewide division of Gondwana coals. Raniganj, Bankura in West Bengal, Jharkhand, Jharia, Gridhi, Bokaro, Daltonganj, Kanapura, Ramgarh. You can pause this and it is very important. Write down all this. Then Odisha, Talcher, Rampur, Hingri, then Sambalpur district, Madhya Pradesh, in Umarias. Singrauli is very important. Chirmiri is important. Sohagpur is also important. Pench Valley, that is also a region in Madhya Pradesh where you will get coal. Then Andhra Pradesh, Syngenetic is important. In Maharashtra, Kota, Chikla, Rajur and Bandar. Then Gujarat it is Gunkeri. All are important for coal deposition. Then tertiary basically you will get lignite deposition. In Assam it Makum, Ledo, Namdang. Presently in Tamil Nadu you will get Niveli lignite field. Niveli lignite field recently occupied region in Odisha, in Chendipada region in Onugul. They are exploring and the mining will start in approximately in 2 years. Then Rajasthan in Palla lignite in Bikaner region. All are belongs to tertiary coal field. So let's come to our question. Which of the following coal field is a Which of the following coal field is a tertiary coal field? So Karnapura, Sangarin, Jharia. All are belongs to Karnapura, Singarin, Jharia. All are belongs to tertiary. All are belongs to Gondwana. Makum coal field. Let's see. So Makum coal field in Assam, it belongs to tertiary. So the Makum coal field, that belongs to tertiary coal field. And remember, these are our class notes. So I've been pasted here. These are from our regular classroom. The bauxite deposit are generally formed by. So we have already elaborately discussed what are the conditions for bauxite formation. So it is residual construction. It is a sedimentary deposition. It is residual. So this is all about your economic PYQs. So hope you all liked the video. So if you like the video, then kindly subscribe and always try to share the video with your friends so they can be benefit from this video. So try to comment on the video so that it will be helpful to publish more videos. And one thing, this we have completed this economic geology. So I have exam in on the 19th. So before that, I'll cover all the PYQs. So this video will be your published soon. Then after this, I'll publish the paleontology part. Then we have sedimentary and metamorphic part remaining that will be also published. Then there is some questions I have missed from 2023 that will discuss in a miscellaneous section, and some questions from geochemistry also remain. That will also will do a video about this. Thank you.